Take you through some more advanced parts of Clojure. These aren't necessarily things that you'll need to solve any of the problems or to work on the Game of Life program. These are just things in Clojure that I think are kind of cool. So I was going to start with recursion. So this is a fair bit of code. Can you guys see it up the back? Yeah? Oh, you've got good eyesight there. So this is using a different way of defining functions to what I've shown you before. So we're still defining a function length, but here we're defining two forms of it. So we have the one argument form and the two argument form. So if you call length with one argument, it'll go in the first block of code. If you call it with two, it'll go in the second. The reason we have defined a one argument form is for convenience, because the two argument form takes a collection and also an accumulator. So we're using that to keep track of how many items we've already seen. Now, you'll remember from when you learned about recursion that we need a base case. So that's what my if statement is for. Once the collection is empty, we're going to stop looping through it, and we're just going to return the accumulator. So that will give us whatever the length has gotten up to. If we still have things left in the collection, then we're going to use recur. Clojure does not have tail call optimization, which some other Lisps do and most other functional programming languages do. Because the JVM doesn't have it, Clojure can't implement it quickly. So instead we have recur. Recur basically does the same thing. So recur will call the current function without adding a new stack frame, and it will let you rebind all of their arguments. So when we recur, we're going to pass in rest collection. So that's everything in the collection except for the first item. So we're basically popping one off, and we're going to increment the accumulator. So does everyone understand how that will take a list and step through it, removing one item at a time and adding one to the accumulator? Cool. So for some of you I've seen out there who are using recursive solutions, you might want to use the recur keyword because, say, if you're calling fib over and over again, it will increase the stack and eventually you'll run out of space. Recur will help with that. Excuse me. Good. You can also use recur within loop. So loop is basically loop's only job is to set a point that you can recur back to. This gives you a lot of the same flexibility, but in a smaller scope. And often we'll use recur either with a function or with loop, where we want to generate some stuff but have more control over when we stop. Because when you're working with lazy sequences, like, it's a good way of getting the data, but if you don't want to process all of it, then it can be tricky to stop. So with loop here, we're initially assigning x to 10, and then when we call recur, we're setting x to -2, what it was minus 2. So loop here you can kind of think of as like a function with one argument, but the 10 is its default argument. We're also using when, which I haven't shown you before. When is kind of like an if statement, but it has no else, and it's useful when you want to do multiple things as part of the if branch. So the only reason we're using it here is because we're using print line, and that lets us view what's coming out at each step. Protocols. So I mentioned earlier that a lot of the functionality that you'll see in other programming languages, Clojure has, but it has it in smaller pieces that aren't tightly coupled together. Protocols are how Clojure gets polymorphism. So in an OO language, polymorphism is tied up in the concept of objects and classes, and so you can swap one object for another object, but you can't really have polymorphism on just any piece of kind of arbitrary data. You need to create a new class normally. In Clojure, you can define a protocol, which is kind of like an interface, independently of any data. So here we're saying that we have the taxable protocol, and sorry if this is a bit small for the guys at the back. And to implement the taxable protocol, you need to implement one method, which is tax amount, and that will have one argument, which is the item. So, of course, Clojure isn't going to have any kind of implicit self or this statement, but instead you'll have to explicitly pass the piece of data that you're working with into any functions that operate on it. So when we have things that are taxable, we then define a new piece of data. So this is a couple of things that are new. Down here, we're defining a new record. So records are maybe a bit like structs, or it's a way of defining a type of data that will have a few fields, and Clojure will define for you for free all of the accesses to those fields. Each instance of a record will not have to have its own copy of the keys, so there's some memory benefits when compared to just maps, and also records can implement protocols, which is why we're using them here. So to define a product, we're just saying it has a price and a name, and if products weren't taxable, we could stop right there, and that would be our whole definition. So that's maybe the equivalent of a Java bean, where you would normally have to define getters and setters and a constructor and internal fields. So it's a lot more concise this way. But then we go on to say that products are taxable, and we're implementing the taxable protocol with the tax amount method here. And the implementation of that is pretty straightforward, I think. It's just the price of the product, and we're using a keyword as a function. So functions in Clojure are basically just an interface. Functions are kind of like a protocol. And so any piece of data could behave like a function if that behavior has been defined. So you can use keywords and sets as functions to operate on data. So here we're using the price keyword as a function to pull the price out of our product, and then we're multiplying that by the tax rate, which we defined up the top. Is everyone with me so far? Cool. So I've got a second example that's perhaps a little more sophisticated. Service represents a specific thing that I did for you. So it would be like, I cut your hair last Tuesday. A service type would be cutting hair. So when you construct a service, you're required to have a type. The type just has the rate that you charge, so that would be like $60 an hour. An individual service will have the number of hours it was performed for, a discount, and a description. And then we're implementing taxable again, passing in the service, and we do the math that we need to get a final discounted price, and then we multiply that final price by the tax rate. Cool? Yes?
Can a record implement multiple independent working protocols?
Absolutely. And also you can extend existing records with new protocols. So say in your date library, you define a date time class, and then you package it up, you ship it. I use it in my project as a dependency, but I define a new protocol that's like Mayan date or something, or like is it the apocalypse yet, question mark. And I can extend your date class to satisfy my new protocol. So this solves what's known as the expression problem, which is a common problem in computing, basically where you need to choose between it being difficult to add new operations on existing data or adding new data to common operations. So functional languages and object-oriented languages have typically taken different trade-offs there, where in a functional language it's, James, help me with this. In a functional language, it should be easier to add new operations to existing data, but in an object-oriented language, it's normally easier to add new pieces of data to existing operations. But with protocols, it's equally easy to do both. Ruby's mix-ins kind of solve it in a similar way, but the issue there is that when I mix in something, everyone else has to see it, whereas with Clojure's protocols, you have to explicitly import the protocol implementation that you want to use. So it's a safer, more namespaced way of working. Yes?
I end up asking my question a little bit, but what does this give you constraints dynamic?
Sorry?
What does this actually give you constraints dynamic?
Ah, good. Yeah. So the thing it gives you is polymorphism. So what we can do is chuck a product and a service in a collection, and then we can treat them both the same way. So I can map over my collection of purchases, and I can call tax amount on all of them. So without protocols, if I wanted to do that, I would need to have some kind of tax amount function that is like checking the type of its arguments, and you would have to define like all of the possible implementations in there, or I would have to define several different tax amount functions, like I would need a product tax amount and a service tax amount.
So this sort of switches, it does basically do the type checking for you.
Yeah. So the protocols will dispatch based on the type of the first argument.
So in our you're kind of got the implicit first argument, which is the object itself.
Yeah. So when we map over this, we'll get back all of the tax amounts, and then applying plus to it is the same as summing. And so out of this example, we'll get $61. And we've been able to address these things without needing to care about their specific types. Macros, you might have heard of. Macros are what makes Lisps awesome. They are the functionality by which we extend the language in ways that you can't normally do in basically any other type of language. Macros are run at compile time, and they transform one piece of code into another piece of code, and that second piece of code is what gets run. So I'm going to take you through a pretty simple example. This does not print hello world to the screen. The reason it doesn't is because we have this apostrophe at the front here. The apostrophe says to Clojure, don't run this code, just treat it as literal data. So instead of getting hello world on the screen, instead we get back the list println hello world, where println is a symbol, it's not the function, it hasn't been looked up, and hello world's the string, of course. And this is why Clojure has lists. Some of you mentioned that it's kind of weird that lists are the same as vectors. We need lists because we need a syntax for calling functions. So once we've got the data, we can just treat it like any other list, right? We can call first on it, and we'll get out the symbol println. And we can remix that data into a new list. So the list function will construct a list, and here we have defined function name to be the first item of whatever this list is. So function name is going to be the symbol println, and we're constructing a new list with a different argument to it. So we end up with this second list. So we've taken some code, we've transformed it in a pretty trivial way, and we've created new code. And this code hasn't been run yet. So if we pass it to eval, it'll be evaluated, and only now will it actually print goodbye cruel world to the world, to the terminal. So to tell the compiler that you have some transformations you'd like to happen at compile time, we use def macro. So here we're defining the emilify macro. It will be passed in some original code, and there's kind of an error in this slide. This code over here is the same as this code down here. Really, this should say original code, but I wanted to keep it in line so you can see what's happening. So we'll pull out the first item, which will be print line. We'll assign it to function name. That's what let lets us do. Let is kind of a way of having local variables. And then we'll use the function name in our new list, goodbye cruel world. So once we've defined that macro, when we call it in our code, it will transform whatever code is in its arguments, and it will run it. So this will print out to the screen, goodbye cruel world. Does anyone have any questions?
Where's the eval?
The eval happens as part of def macro, so it's kind of bundled up in there. We don't need to explicitly eval it. Def macro just will pass you some code as data, and it expects you to return some new code as data. And then it handles compiling it and loading it into the system.
So that when you define a macro, that expansion happens at compile time. And so then when it goes to run the code just like normal, it just finds the normal piece of code and evals it like normal.
Cool. So this is how a lot of Clojure is implemented. Let itself is a macro. Def macro is a macro. What else? Things like and or are macros. A lot of Clojure is written in Clojure, and we're able to do that because of macros. In some of the examples I showed you earlier, where there was like def routes and get, these are macros that have been written in libraries so that we have these really concise concise DSLs. Macros are a way of doing metaprogramming, but I think they're a lot simpler than systems that you'll see in other languages, because you don't need to mutate any state. It's just normally a straightforward transformation from one data structure to another, and that's the kind of code that's expressed really well in Clojure. So that's some more advanced features. This afternoon, I was going to suggest that we get started on the game of life, which I would expect would take a couple of hours for new people. If you're getting through the original examples and you're having a good time, then please feel free to continue. But we'll all be around to help with either the original examples or the game of life. Yes?
I assume that the macro is correct, the macro don't have problems that do it. See, is it not textual, correct?
Yes. So macros in Clojure always deal with actual data structures and not just like strings. So they, I don't know. I don't write macros in C, but I'm led to believe they can be a little flaky. Yeah. Yeah.
They can still be there in the edges and watch out for things like variable capture and stuff, which you kind of defining a data structure in outside of some context and then into this context where there might be variables that the names that you might capture inside that. There's ways around it.
Cool. Thank you.
One more thing, sorry, because I don't know, people might disappear and the like. If anybody's loving Clojure, thinking it's awesome, and looking for a job, our clients, this is not for ThoughtWorks, but our current client, IOOF, have 2 open jobs for Java developers who are going to be doing a fair bit of Clojure. So if you go on to Seek and you search for Clojure jobs, there's a senior and a more junior level Java developer jobs there looking for Clojure experience. There isn't much Clojure experience, Clojure enthusiasm, and good Java experience will probably get you there as well. So I can send around the URLs, but if you go to Seek and search for Melbourne Clojure jobs, you'll probably probably be the ones that show up.
And I guess I should mention as well that I run a Clojure users group, runs every second Thursday of the month. So you can find that on Twitter.
And actually, if you're interested in the IWF jobs, also just talk to me because you know we're going to be helping the client do the whole interviewing process as well. So yeah, worth knowing who's putting their hands up or not. It could make it easier to get the job. Yeah.
You've probably got the right algorithm, just the wrong, because it's got the right answer for the